The factor theorem. If we calculated f of c, which remember would give us the remainder on division by x minus c, and it was equal to 0, that would mean there is no remainder, and therefore x minus c must be a factor of the polynomial. This works exactly the same way as it does with numbers. How do we know that 2 is a factor of 8? That's because when you divide 8 by 2, it goes in 4 times with a 0 remainder, and therefore it's a factor. Works exactly the same way with the polynomials. We can use the factor theorem to find factors of polynomials, which is useful when we want to factorize them, and that helps in solving them the same way as it does with quadratics. If p of a is equal to 0, then x minus a is a factor of p of x. If p of b over a is equal to 0, then ax minus b is a factor of p of x. Remember, when there's no remainder, our p of x would end up being, let's just say, x minus a q of x. And that's it, because there is no remainder. The remainder is 0. And therefore p of a would be equal to 0, because a would make that bracket a minus a, which is 0. Same thing happens here. We're dividing by ax plus b, so our p of x would be ax minus b q of x. And if you substitute into there b over a, what happens here? We get a, b over a, take away b. A's cancel, b minus b is 0.